All the examples in this video revolve around FDM 3D printing technologies. FDM machines utilize real thermoplastic resins, real, strong, tough materials for real applications. FDM technology is a premier choice for creating complicated parts that need to stand up to repeated use, drilling, tapping, and getting banged up. In this first example, we have an application where we have two different tooth belt pulleys that need to be driven by a roller chain. These are going to be mounted to a common shaft, and we want them to take up as little space as possible. To create a complicated part like this, commonly you would go find online and purchase the components separately, the sprocket and the two timing belt pulleys you need. Then, a lot of times these parts are going to have to be modified to fit your application. In this case, we're going to have to wait for the parts to come in and then mill off the boss here, add some holes, and probably mill the inner diameter to the right size. We would also need to modify the sprocket and the other pulley. Then we need to figure out a way to merge all three of them. Overall, it's not a great or easy solution. Now when I see a problem like this, I look at the design goals of the part. Which features need to be made out of metal, and which features can be eliminated? I try to think of a better way to make this part with additive manufacturing technologies. I know that the roller chain sprocket is going to have to be made out of metal, because there's a lot of force on that part and we want the high wear resistance of the metal. However, I'm confident that FDM plastic will work just great as the timing belt pulley. So using CAD models, I was able to pull off the manufacturer's website. I designed this part. It incorporates both pulleys on either side, a metal sprocket, and also two embedded ball bearings, one on each end. Now what makes this all possible is Insight software that powers Stratasys Fortis level machines. Going from CAD into Insight, I have full control over all the build parameters of my part. With this, I'm able to remove support material and insert predetermined pauses into the build. Send that to the printer and we're on our way to creating a part that encapsulates several pieces of hardware and design elements into one cohesive part. A small assembly that would otherwise have taken lots of waiting, machining, and assembling can now be built unattended on an FDM 3D printer. Not only can 3D printing help us design and iterate faster, but it can also allow us to create parts and products previously thought impossible. This illustration here shows how we were able to turn this part into its bare essential components and reduce the overall width substantially while maintaining functionality. And once we've created that design, it can easily be copied for producing multiple parts. And here's the final part, a functional part that incorporates metal and bearings where needed while requiring no machining or post-processing. I'll quickly go through some other valuable examples using this same technique. Hex nuts. Try using drop-in captured hex nuts next time instead of threaded heat set inserts. Hex nuts are more widely available and much cheaper than brass inserts, and using this technique, they will be more resistant to rotation and more resistant to pulling out in both directions. Dropping these into the middle of a build can also be faster than adding heat set inserts later. So next time you need repeatable, strong threads in a 3D printed part, consider this option. Also in this part, a fully captured bronze bushing. Insert, press it in, print right over it. Again, the idea here is to recognize that you aren't just limited to plastics when 3D printing. You can still use and incorporate your metal, plastic, and composite hardware into 3D printed parts to get the best of both worlds. Another case here of solving common problems. Take a look at this part here. There's some large overhang features that need to be supported. The shelves inside the cylinder are floating there. There will need to be a considerable amount of support material used here, no matter what orientation we choose. Right side up, upside down, no matter what, there's going to be a lot of support material, and that's going to add a lot of time and cost to this part. But consider this, with FDM technology and the help of Insight software, I can break this model apart and assemble it mid-build, in effect using almost no support material and reducing the build time by 50%. These internal baffles were printed separately, flat on the build plate. The model printing is paused at the point that we determined. One of the baffles is removed from the build plate, flipped upside down, and inserted into the top of the build. The printer then continues to print on top of it. We do this again for the second baffle, and a few hours later, we have a completed single part that printed in half the time and saved tons of support printing and removal time. This is a breakthrough technique that isn't possible with any other 3D printing technology. I genuinely believe FDM is the most advanced, diverse, and useful 3D printing technology out there. Thinking further outside the box, here's inserting a section of roller chain into a nylon FDM part. This application will help speed up mock assembly of real metal components that will be added later. Or this application that requires a continuous section of tubing, but also needed steel mesh on either end for filtering out large particles. Using the power of Insight and Fortis 3D printers, we were able to pause the 3D printed build and insert some off-the-shelf mesh discs to create a part that couldn't be made any other way. One of our favorite parts is this quadcopter arm. We found that we needed to increase strength and reduce deflection on this part. We accomplished this by cutting some pieces of carbon fiber rod to length, inserting them into the channels of this part, and embedding them in 3D printed plastic. The resulting part is incredibly strong, thanks in large part to the carbon fiber rods inside. In a lot of applications, you may not need a printer that prints in carbon fiber. or a printer that prints in metal. Maybe only part of your design needs to be metal or composite. We believe that Fortis FDM 3D printers allow engineers and designers to do incredible things using metals only where needed and using the 3D printed plastic to supplement the other features of the part. Wrapping up the examples I gave today, I showed captured bearings and sprockets in the pulley example, captured bushings and hex nuts in the bushing block, roller chain inserts, mesh filters, carbon fiber rods, and even other 3D printed